difficult. Right? So it used to be we'll just set this malicious echo. Because if you think about it, from a corporate environment, RDP files are used all the time, right? You get some remote desktop that you're shared for terminal services.
Sorry, you're good now.
Okay.
Apologies.
Yep, you're good. My mic just quit working though. Hold on one second. The mic's working, but my mouse is not working now.
All right, I did fix the audio for the recording.
Let me just try this one more time. Let's see if that works. Yep, it's not working. Let me see. There we go. Sweet. So remote desktop. So looking at remote desktop, the things that I've noticed were that RDP files are not blocked by email clients. Why? Because business continuity says that sometimes we need to send RDP files to our employees so that they can access the remote workstation. And so that's a really good indicator for us because that means we could email RDP files to our targets. They're not blocked by security providers. So if you're using like Proofpoint or any of the security mail gateways, then they'll fly right through by default. I mean, you could obviously configure these rules up to block these. And then Outlook, Office 365, all of these mail providers are also permitting RDP files by default. And so this was just kind of me generating a bunch of the extensions and randomly clicking, and then bam, RDP pops up. And so RDP files are a really good indicator that we could leverage that. So, but when you start thinking about this, what does RDP provide to an attacker in the event where an RDP file was sent in? And so the thing that we could actually do is there's a lot of stuff that comes with features within this. So RDP can be configured with the RDP file to actually pass through network file shares, for instance. So let's just say that there's a mounted network file share as Z drive or something that you automatically provision with the group policy for all your employees. So those map network drives are available through a session of RDP. Then you have read-write over the client drive. So on the C drive, you could do binary planning. So if you think about that from the aspect of dropping a beacon in the startup folder or some other sort of persistence, you could just drop it there. The other cool thing is it actually forwards the local printers of that network. So if there's printers there, it'll mount it and become available on the terminal services client. Because Microsoft really wants to be able to enable this remote workspace so that it's seamless with the clients that are connecting to it. And it creates a massive vector for that. With that, you also get the clipboard contents. And this is actually really cool because in my research, I was in a virtual machine launching the remote desktop in order to connect to my rogue server, which we'll talk about in a minute. And the actual clipboard content from my host computer outside my virtual machine was forwarded to my remote server. So now you have this other problem where network files or shares that are mounted on the host computer that are forwarded to a VM become available as well, because the clipboard's usually there by default. And so you could also look at the audio devices. So think about audio and video or any sort of USB components that are plugged into the machine. You could actually set RDP up by default to forward all of the devices from that local machine from your target to the remote session. And we'll talk about why that gets really bad in a little bit. You can do cameras. The other cool thing is in some cases, you can do remote code execution directly. So as soon as that client connects to your rogue server, there's ways that you could actually execute code on that computer. We'll talk about that in a little bit in the conditions that are required around it. But if you look, Microsoft Terminal Services has a wide variety of attack vectors that we could leverage. And so the cool thing with that is we can actually configure MSTSC or the RDP file on our own machine and then just send it as a file attachment. And we can send it to any mail client because it passes through all the mail gateways. And it bypasses all the mail providers and all the security gateways and everything else. So we're basically evading everything from end to end. So it's a really great initial access vector to kind of consider. The only problem with this is we need a really good RUSE. And when you're sending somebody an RDP file, in the corporate environment, what do you typically see, right? So you think about this from the outside the box because you're going to need to tailor the attack vector to your targets in something that they're familiar with. And so the way that we do that is using a really good RUSE. And so the cool thing is, with social engineering attacks and all of this moving to other verticals and not necessarily having to stay on email anymore, we can go back to email now. And so because these RDP files pass through, we don't have to worry about security gateways. And so what we're going to try to do is we're going to try to entice a user to connect to us. And it needs to look legit. And because obviously we want them to be able to open the RDP file connection and then do some cool stuff. And then if we, in the email RUSE, if we provide some sort of out, right? If there's concerns or questions like I'm not expecting this, we need to be able to provide them a decent way to get out of that without reporting back to their security teams. And then we can forward them on after they're done. And so we kind of want to think about all of this because you don't want to leave red flags and you don't want to leave anybody concerned that they just opened something because then the security team is going to be on you. And then when they're on there, you got a limited time and you got to move quick and lateral movement and pivots and everything else has to be done really quickly rather than go low and slow like we would all like to do. And so this works really good if you're on an internal network because if you have it on an internal network already, you could plant RDP files on like network file shares and it just makes it really valuable. And so the way that we're going to do this is we're going to set up a fake remote shared workspace. And so I tend to go to LinkedIn, look at what jobs they're hiring for, or look at what engineers they have on their teams already, and then find out what technologies that they're well versed in. In a lot of cases, this was a real one that I used from Citrix Workspace. And if you'll notice, I template the email because I usually send these in bulk, so I'll send like 10 at a time or something. And I'm basically spearfishing like 5 or 10 people at a time, but I want to be able to search and replace the target, the sender, and all of that. But we're testing a new shared recruitment environment, need your help. Please verify your access as soon as possible to avoid service disruption. The attached connection file will automatically connect you to the workspace. So we're telling them what they can expect. That way there's no red flags. So I would automatically connect you to the workspace. The invitation is going to expire. And so that because it's expiring, it creates that urgency that we're trying to get them to do before something else happens. We don't want to interfere with business. So they're going to want to click on it. And then this is a real Citrix Workspace email. I just swapped it out with my own stuff. And then you'll see the Workspace RDP file. And then there's an attachment on there. And it looks really nice. The cool thing is at the bottom, I put in the event you're unable to connect, to the remote workspace. We don't want them going to the security team, or if I'm phishing them from another employee, we don't want them to go to that employee. So what we'll do is we'll say, if you're having any problems, please fill out this form using this link. That way they just report it to us and it just goes to dev null. We don't care. And so that's how we kind of let them down from the RUSE. And so now the RUSE delivery is really interesting because we're once again back on email, but it doesn't have to be email. You could do this through LinkedIn. Lots of social networks and team collaboration tools will pass RDP files through flawlessly. So start thinking outside the box whenever you're starting to send these RDP files. You could plant them anywhere. And then the other cool thing is when I was mentioning with the network file share replacement, we'll talk about how that's going to work. But if you're on an internal network and you find an RDP file that's there, this technique that I'm going to show you will give you the ability to replace theirs with yours and not interfere with their normal connection. So it'll pass right through. They'll still connect to their normal resources, and we'll talk about how we do that with man in the middle proxying the RDP protocol. And so that's basically what we're going to be looking for. This is what we're going to deliver. The cool thing is I have a bonus here. This is a new one that's relatively new. I'm not really sure exactly where I learned it from, but I learned it from a friend who learned it from someone else. So I don't know where the original came from. It hasn't been talked about really publicly. I think Steve Boros from Black Hills is doing a blog post on it this week, and so you'll be able to see more about it. But the cool thing with this is we can actually spoof from Office 365 to Office 365. And so the reason why this is valuable is now you can imagine, like back in the day, you used to be able to spoof emails and it was this big thing, and now you get DMARC or you get SPF records that are set or DKIM, encryption certificates. But we could bypass all of that by going directly to the mail connector for Office 365. And so it's enabled by default for Office 365. It's using this thing called direct send. And it's a way for being able to send bulk mail, but it bypasses everything, all the mail gateways and security controls that are in place. You go directly to the Microsoft connector. And so it's a smart host is what it's technically called. And the reason why it works is because they don't want to route the domain that you're sending email to as a spam domain, so it just automatically goes through. I don't know what Microsoft's deal is, but if you look over here on the image over in the middle, there's a pink box that says your MX endpoint. So it's your domain-com or whatever TLD you have, .mail.protection.outlook.com. The really beauty behind this is there's no authentication. You literally just connect to that mail connector on port 25 and send SMTP as you normally would. There's only a few caveats with it. You need to be able to get the MX record. This is the way that I do it. I just use NS lookup. I query the MX record for my target domain. So whoever the target is, I target.com it, and then I'm able to connect to the SMTP server on port 25. And it's usually always the name of the domain dash the TLD .mail.protection.outlook.com. One of the only caveats is you have to be able to send from and to a real user that's on there. So you want to do some user enumeration before you're actually using it for your RUSE. And then the other thing is you basically have to know that the smart host of the domain is the right host. Outside of that, you're really good. Once you have the recipient account and the one that you're spoofing, you could just send it directly to it, and it works on a lot of O365 domains. I mean, we've used this on pretty much most of the targets, and it goes directly into the inbox. And so you're basically spoofing whatever you want to spoof. You could spoof another user, you could spoof a distribution group. As long as that user account is enabled and it's not just an alias, you should be good to go. So that's just a little bonus slide. And so let's talk about bringing our own server, because this is probably the most important part, right? I mean, we could send RDP files all day, but if we're not sending them somewhere to connect to, we need to make sure that that we nail this part more than anything, because this is where the code's going to be running, right? So think about running your own Windows server, and you could put it in the cloud. You could expose it if you want. I'm going to show you how you could do it without exposing it, but the idea is you're running your own RDP server. You spin up a Windows server, you configure RDP, and you bear in mind that RDP file is going to auto connect to your server. So there were some logistical issues that I had with researching on how to pass in authentication and how do I do it where I'm not exposing my RDP server to the internet, because Russia and China are going to be there beating down your door within minutes if you have exposed port 3389. And so you could change the local port. There's just a quick way to do it down there at the bottom. But the idea is that you're going to want to open RDP in the firewall, set up your server, set up a new user that has RDP permissions. Now, bear in mind, your malicious code is going to be running on your own server. But what happens is when the client connects to the server, you're actually able to access the hard drives and all of the devices on the connected clients. This is where the beauty comes in. And so now we're looking at RDP. There's lots of protocols with RDP that we'll talk about, but the hard part about this was really on the credential loading. So if you're familiar with DP API within Windows, anytime you're storing encryption, your encrypted credentials, it's based on the DP API of the computer that encrypted the credentials. So if I encrypted them and then put them in an RDP file and saved it, and then sent that RDP file to someone else, that person that opens it's not able to actually decrypt the credentials to use them for the connection. And so I was like, okay, what if we just use like a blank account, which is super bad. Don't ever really think that's a good idea. But I wanted to try because this is progressing through how to force the client to automatically connect to us. It does require a little bit more interactions. You also get this really ugly yellow banner, which is always scary whenever somebody clicks on it. You want blue, right? Windows. Yellow is bad, blue is good. So we need to be able to get rid of that yellow banner. Blank account passwords are going to expose the server to the internet, which means anybody can connect in. And while we're running malicious code, so that's not that big of a deal, we don't want to accidentally hack someone outside of our scope. So we want to make sure we stay in scope. So it's super risky. And then there's also the unverified banner that we're going to get rid of here in a second. And then if the publisher is unknown, now we have another issue, right? Because it's sketch. It says publisher unknown. Like you see that, you're like, I'm not clicking on this. I'm not connecting. And then outbound 3389 might be also blocked, right? You're like, oh, well, you know what? Outbound RDP over the internet, we're not going to allow that. We block that at the firewall. Okay, well, that's great. But we could set whatever port we want, and we could pre-configure the RDP file to use :port, and it'll just automatically connect over that other port instead. And so that's kind of the catches that we have. And so the solutions that we have is nice and blue. The way that we do this is we're gonna man in the middle the client. So they're going to connect to our proxy server. Our proxy server is going to connect to our real server. The reason why that's really good is because first we could firewall off only our proxy to be able to connect to our RDP server, and we don't have to worry about anybody connecting in. The other thing that it really does is it gives you the ability to create whatever username you want for the RDP file. It doesn't even matter. So what I try to do is I try to tailor that for my target. If it's a department that I'm targeting, then I'm going to use the department name for my username. You just want to make it look as legit as possible. But the other really good thing is you could just generate a real SSL certificate. Now there's some funkiness that you have to do. Like if you're wanting to use Let's Encrypt, for instance, you could convert the Let's Encrypt encryption certificate to like a PEM and then import the PEM into Windows and use the thumbprint to sign the RDP. We'll talk about that in a minute. But we're going to sign these RDP files with our own SSL certificate that matches some doppelganger domain of the company that we're targeting and make it look nice and pretty. And then we're going to sign it using a built-in tool within Microsoft called RDP Sign. How novel. And so we do that. It's signed. There's no mark of the web. We're sending this over the wire. We're good. Everything's great. It'll pass through. And then when they open it, it's just going to look like that, nice and blue. They click connect and it's game over. And so the other really cool thing with this is we could set our proxy server to listen on whatever port you want to listen on. So if you wanted to set it for 443 or 480, you could certainly do that. And you're basically connecting RDP over those ports. But I mean, who cares? It's just a client connecting into you anyway. And so that's the way that you can do Let's Encrypt. I threw this in the slide deck in case you wanted to go back and reference the slides later because it was a little tricky to kind of convert this stuff, especially on a Windows machine. You had to install Cocoa and OpenSSL in order to get the Python 3 certbot to actually work properly. Once you do that, you just generate your doppelganger domain. And then you could actually use OpenSSL to convert that certificate and that key into a PFX, which imports directly into the cert store within Windows. Once it's imported into the cert store, it'll provide you with a nice little thumbprint. You take that thumbprint ID and you pass it to RDP Sign and point it at your RDP file and it signs it and everything is super great. There's probably a much easier way to do this. This is just me kind of hacking the solution through because I have no clue what I'm talking about with this kind of stuff. I just have to figure it out as I go. So there's probably a better way. And if you do know, feel free to reach out and I will update this. And I'd love to find a better way to do it. And so, so the proxy, let's talk about the proxy. The proxy is really interesting because in order to proxy RDP traffic, you have to do all kinds of protocols. There's fast protocols and short protocols, and there's these fast paths and low paths and encryption protocols and communication protocols. There's lots of binding for the GUI. So there's lots of protocol binding to be able to get the user interface from the Windows server to pass through your proxy into the client so they can render properly. There's all kinds of specifications, and this rabbit hole goes really deep. So I was looking. I started looking at like free RDP. I started looking at X-free RDP. All of these different protocols or these software packages that were open source that kind of already implemented it, so I can try to avoid this part of it. And then I came across a tool called PyRDP. Now, PyRDP implemented all of the protocols. So it's the TCP, the segmentation, all of the encryption, the security stack, everything. They did all of it in Python. It's already put together. You don't have to do anything. You just tie it together. And they put it in a really cool tool. So they built all of this. And the hard part about this is you have to remember, we're proxying the redirectors for the file access, for the drives, for the audio devices, for the USB devices. So there's lots of communications between the client and the server that we have to account for if we're going to leverage this in a RUSE. And so PyRDP is amazing. It wasn't built for this. It was actually built for honeypots, like an RDP honeypot. But PyRDP actually monitors the clipboard content for you, so I don't have to do it on the server. I could do it on the server, but it actually implemented it in the Python library already. It does actually hijack any of the host clipboards. So in the event where there is something on the clipboard, you could write to that clipboard of your target, or you could just monitor it and then copy off and save stuff. Has built-in crawler. This is super cool. I have a demo at the end of it. But it will actually enumerate all of the files and all of the drives to a list that you're looking for. So you could set up a list, pass it to the crawl, and it'll look for all those extensions. So like .configs or .aws or .azure if you're looking for like some sort of cloud credentials on the machine. It'll enumerate all of them. And any of those files that it finds, it'll download them directly to the proxy server. So you don't even have to worry about writing it. I wrote it all in C# and did it on the server, but this had it in there, so I have kind of both now. It does actually implement most of the specifications, but one of the big things is all of the GUI bindings, it's already there. So we're good on that side. The cool thing with PyRDP too is you can actually replay that entire session. So if you wanted to replay the user interface aspect of it, it has that built in. You could pass in the certificate and the key and listening port, and it'll basically just listen on that port. So if you wanted to listen on 443, pass in your certificate and your key, it'll listen on that. That way everything looks good. And yeah, and the beauty part behind this part is it actually solved for my credential issue. So having to log into the server without exposing the server meant that I could pass in the command line, the real RDP server, the real username and the real password, and the proxy will connect to my rogue server. And now it doesn't even matter. Whenever they click connect on the RDP file, it's just automatically going to log them in and map all the drives and take everything that it needs to take. So it's super good. And then the cool thing with this is you're thinking like, okay, well, my client's going to have some sort of EDR. Maybe they have the latest and greatest secret sauce stuff, right? We're running server-side code. So that server-side code is not running on the actual target. It's interacting with the devices of the target, but it's not actually running in memory space on the target, which means no EDR. And so we get to bypass kind of all of that. And so when you're thinking about this, we need to be able to run some sort of payloads on these machines, right? So our malware that's running on our server is running at login. So the way that I usually do it is I just throw it in the startup. But you can set up a GPO policy that kicks off a file. You can do whatever you want, but once that session is established with the server, it's game over. It literally will immediately start attacking it. And so what I like to do is I like to plant like an LNK file on the desktop. I'll do like an LNK with like a spacebar shortcut, right? So every time they hit spacebar, it's going to launch my LNK. And I'm going to plant my binary somewhere. So yeah, there's a lot of payloads that get executed, or you could execute it and then delete the payload immediately so it doesn't run again. And you could do some side loading. So if you're familiar with any of the DLL side loading stuff, you could drop like dbghelp.dll in the Microsoft Teams folder so that whenever Microsoft Teams starts up, you have your persistence and it's in user land, so you don't have to worry about having elevated permissions. You could do some of the app domain injections if you're familiar with like .NET, where you could update the .NET configuration file, plant your DLL or plant your executable, and basically hijack the app domain for .NET. All kinds of cool ways you can actually execute code on startup for persistence within userland. And then the other thing that I want to do is I want to be able to look for any of the sensitive files. I'm looking for credentials. I'm looking for GPP stuff on the network file shares if they're mapped. And we want to be able to do all that because when we compromise the target machine, we're going to use that target machine to pivot to the network file shares and search those for stuff as well. And then obviously because it's not running on the client, lots of cool detections. And so server-side payload. So I have a little section on this, even though PyRDP kind of happened to kind of implement a lot of this. So the client interaction. So I did most of this stuff in C#. And the idea is there's a library called Cassia. It's really, really cool. And it gives you the ability to interact with the terminal service client that's connected to your server. So it's basically server-side code. Little tricky to write because you're having to like install Visual Studio on your RDP server and then debug it, step through the debugging sessions and stuff that way. But in a nutshell, if you remember anything, this is all you really have to remember in order to do it. If a client connects to your terminal server and you have code that accesses // TS client / C drive or C, then it's going to interact with the connected client's machine rather than the actual server's machine. And this is where it gets really fun because now we can start leveraging this in all kinds of different cool, unique ways. We can enumerate the user folders and start looking for which users are there and their startup folders and plant binaries for startup. And then there's all kinds of other stuff too. Like I've tested with RDP Gateway. RDP Gateway works, but it doesn't work with PyRDP. So if you're familiar with like like the RDP gateways, we're looking for something for like a low-level privileged escalation or code execution. So I have one that I'll talk about here in a second, but we're looking for ways to execute code without having to wait for the computer to restart. Right now, it's not that big of a deal because if you're on like a red team and you're using this, then they're going to eventually restart the machine anyway. But that waiting game is where we get burned because if we're on a 1 month red team engagement and we have to wait 2 weeks for them to restart the computer, well, then we got a problem. And so, and then anything from that mapped VM host, like I was mentioning earlier, if you have a mapped drive that's shared with your virtual machine and they're running that RDP file from a virtual machine, it's game over. It's a VM escape on your client computer. So we're good there. And so this is just some of the code. I threw this in there just so you can kind of have it in case you wanted to interact with it and play with some C#. I just threw this in there. I have some code that I haven't released yet, just for other reasons. But yeah, it's pretty cool. It gives you some deep information about the IP addresses. It'll give you some of the client information, the Windows station name. It'll give you the username of the target's machine, so their local machine that they're connecting from. So you know kind of who's there, and you can get the display information and resolution and all that. You can get other stuff like the printers and whatnot if you could do that and enumerate those. So there's a lot of valuable stuff that you can get kind of from that library. It's super powerful. And so this is our attack path. So on the red teamer over here on the left, I'm going to send my RDP vish to my victim's workstation. We're going to execute, they're going to execute that RDP file. I'm going to be able to access the mounted network shares using the TS client server. It's also going to connect them directly to the PyRDP session. The PyRDP proxy is going to connect to our rogue RDP server, and then we're going to plant a binary back on that workstation so that we can get C2 and then just imagine our command and control system kind of working, and that's kind of the way that that's the attack. So hopefully this is going to work. Let me see if I can figure out how to share this with this tool here. I'm going to see if I can get this demo. I don't know if it's going to work, but we'll. So I got to get this presented sometime.
This one?
Yep. That's not there. So we got to share it with whatever streaming software. Yes, there. That's all the desktop. Sure. Yep. Maybe not. Let's see. Let's go to presenter. All right. That's why we started a little bit early. Yeah, it ain't working. Demo ain't gonna work. Yeah, I know. Needs some Windows help. Actually, I don't know. So let's see if that'll work. Where's the folder? Nope. Okay, no big deal. Okay, well that ain't gonna work. So it was a demo, but they have some recording software that's not letting me share the demo. I did pre-record it, but this is why I bring my own laptop normally. But so the demo basically was going to walk through all of that. I'll tell you what it does. So the concept is once that RDP file gets executed, it connects to the proxy server, and the proxy server is going to connect to the rogue RDP server. Once it does that, the binary planting actually creates an LNK file on the desktop with the spacebar, and then writes another payload to the startup folder just for sake of persistence. Once that machine, so the interesting thing with RDP files writing the file to the LNK on the desktop is that the shortcut doesn't actually take effect until the computer restarts again. This is with the exception of unless you have Hyper-V installed. If Hyper-V, this is an interesting little excerpt on executing code on the endpoint target without having to worry about restarting the machine. Hyper-V actually will create a process that runs if you print to the machine. So think about from the computer's perspective, you have Hyper-V installed and you're wanting to print within a Hyper-V environment. It runs a program called wfs.exe within the Hyper-V folder. Remember that the printers are actually forwarded to the rogue server. So what we do is we create a symbolic link. We write the file to the wfs.exe in Hyper-V with our payload. This is our beacon or C2 or whatever it is. And then what we do is we create a print job on the local printer that's being shared with our server. And when that happens, that print job in Hyper-V actually kicks off our beacon and we get remote code execution without having to worry about a machine restarting. And so it's super valuable. It gives us some really cool stuff, but we're looking for new ways to do that as well. There's probably other audio or USB camera or certain models of laptops that will give us the ability to execute stuff. But the goal is we don't want to have to wait for the computer to restart. So once that rogue RDP server is interacting with our victim, we want that victim machine to run our beacon immediately so we can have our C2's channel established. And that's pretty much the nuts and bolts of the demo. There was some other cool stuff where I was going to show you the clipboard, and then I had in the demo, I actually had a mounted USB drive that was in the host computer. And so what happened was I was able to look for a specific file extension on that USB drive and actually exfil it off across the network without even worrying about it. That could have been anything. It could have been a credential file. It was just a demo file, but just to kind of show the impact of this. But yeah, so that's RDP in a nutshell. And so for some closing thoughts, because we're getting short now, but so the remediations for this are that you want to really set a GPP or a group policy setting for the remote desktop session host, because you don't want that host to be able to share their local drives with the external connection, right? You want to make sure that that's locked down. And so there's a lot of device and resource redirection that you could disable, like in the video and the screenshot right there. So there's everything from USBs to network file shares to all of that, where you could actually restrict that from being shared out. This is the best way to do it, but you have to do it in a policy that's going to spread across the network. Otherwise, if nobody's has this enabled, then they're prone to be a victim. You can block 3389, but you notice that it's still only going to make it more difficult just routing around 3389 and using another port. But it's not a bad idea to block outbound 3389. And so the other interesting thing is, so if you're familiar with like COM objects, so COM gives an object interface to remote desktop sessions. So I created this initial access technique in order to get around using macros, because if you didn't know, macros are dead, or they're going to be dead here in a very short time. So Microsoft finally decided to say that macros downloaded from the internet are bad, right? Like we should have known that, but They're bad now, if you didn't know. So they're going to be disabled by default. You're not going to be able to run macros. And so this came out of that. But in the event where you still found a way to get a Word document or something with a macro that's bad and into the target's network, you could actually use the macro to create a COM object for RDP. So you could do all of this from like a Word doc without actually having to send an RDP file. Now, obviously, the whole idea was to send an RDP file because it's not being blocked. But in the event where you wanted to use a COM object or use something like that for persistence or for executing code, you can instantiate the COM object. You can even set it where it's invisible, where it's not even going to pop open the GUI interface for Microsoft Terminal Services. And so the idea behind that is it's going to do the exact same stuff. It's going to share the network. It's going to do everything you would normally do, just run in the background, and COM is COM. So there's some really cool stuff you could do with COM objects. And so yeah, that's what I would say watch out for. So that's pretty much everything that I had. I had a demo, but obviously the demo is shorter than this. So, but yeah, I have some time, I guess, for questions if anybody has any questions. Is this running through a perimeter network? Correct, yes. And so that's the beauty behind being able to change the port, right? So you're going over the internet, you can go through the cloud if you wanted to, but it's basically creating that connection outside the network, whether it's through, because it's connecting out, right? We're not connecting into the network, so they're connecting to us. So the cool thing with that is wherever they're at, as long as they have internet activity, they can connect into our server. So great question. Yeah, so great question as well. So the question was, once we get that established C2 and we're connected to our target, how are we doing it? And that's all going to be based on the actual engagement type and the scope of the engagement. So typically I use this on red team engagements, right, where it's a little bit more low and slow. And so a lot of that is really situational awareness at first. Once I establish that connection, I want to know where did I land, what process am I running as, who's logged into the machine that I'm logged in, where's that machine, and you want to do that really slow, right? Because the moment you start hitting stuff and running Bloodhound is the moment you're going to get sock beaten down your door. So you want to be able to blend in. You want to tell a story, right? So what I try to do is I try to have my beacon or the binary that I'm planting tell that story. And so think about it from when IR comes running and they're going to triage that machine, what are they looking for? They're looking for certain processes. They're looking for, this is a weird process, or this is a child process of a really weird parent process that's phoning home to the internet, but it's like Notepad. Like they're looking for weird stuff. So if you tell that story and you blend in and you do, your parent ID spoofing and you set up your payloads properly, then you could you can do your Bloodhound and lateral movement and escalations. But it all depends on the scope of the objective, really. But that's usually what I do. I do use Bloodhound and Sharphound. So.
Is there a password collection opportunity in that proxy?
So when you say password, do you mean?
Like with the RUSE, you're presenting this as we're going to travel to system, and you configure that proxy to be able to collect users' passwords. Like use your password.
Yes. So the cool thing with it, it does capture it if there is a password. But because once they click connect, there is no logging in. It's automatic because we're logging in for them. But in the event where, like with your example, like let's say you found an RDP file on the network file share that they needed to type their login and password in. What we can do is we could point our proxy to the real server, change their RDP file to our proxy, and then when they do log in, we capture credentials as well. So that's already built into the proxy. Yeah.
Is there a good way to remove leftover files after attaching to RDP?
So that's more manual because I think, when you're planting a binary or any file for that matter, only you would know where you planted it. And so what we do at Black Hills when we're on our red teams, what we do is we keep track of our artifacts. So any changes that we make, if we make a change to a password or add a user for whatever reason, or write a file somewhere, we always keep track of that because at the end of the engagement, somebody has to clean this up. And so we want to make sure that we're doing our due diligence to make sure that whatever organization we're testing has the ability to see what we did and be able to take those artifacts and delete them. Sometimes I'll delete them if they want me to. But yeah, so that's the best way to do it. I don't know another way to do it like manually. I mean, I don't know like a tool or anything, but I would definitely, I think I would do it manually no matter what because it's more important to make sure that you get all of the artifacts properly. It's a great question. So I didn't spend a lot of time on all of them, but most of the default ones that are within Windows, I opened up. There's some graph programs for like performance and weird stuff, but I didn't see anything that I could leverage for an attack vector. There's probably a lot of unexplored attack vectors in some of these default programs, though. I didn't spend a lot of time. I did also look at, there's some, I think it's WSIX or something. It's the new, it's some new Windows remote thing. I don't know. It's like on the new app.net, whatever it is. What is it? I forget. There's some new framework within Windows that gives you the ability to do stuff, but it was like click once. It's like the new click once is what it is. Remember the click once from like a couple of years ago where you could install it and it'll like download it through Edge and just run your code. It's like a new version of that, but it's for like the new modern Windows through the App Store and everything. I did play with that a little bit, but there's some really good safeguards with those vectors because they need to be signed or in the certificate store already. So you kind of have to figure out how to do that. But
yeah, so how often do you have Hyper-V installed on your machines? Because I can't imagine that the tech support guy has Hyper-V on. That's my question.
yeah, that's a good question. So you'll notice that so when I talk about Hyper-V, it's always just been in theory. I've seen it, and I'll even be on Twitter and I'll say I've never seen it in the real world. I haven't found it, but I haven't also looked for it, so I don't know how often it's really there. Some of these times you don't really know what you compromise either. So like you might not like I go after security engineers, I'll go after the IT administration, like I'll go after anybody with any sort of elevated privileges. That's usually who I target because in your mind you're thinking, well, they would never do that. But the reality is that we all will do that with the right ruse. So I kind of go that way. So
So I got lost a little bit as far as where you get right into this permissions. Is that because RDP, like Windows default RDP implementation is overly generous and treats like the C drive of the connected machine as a shared drive?
that's correct. Yeah, and so it's so by default in the Microsoft Terminal Service Client. Remember, we're creating the connection file, so we just enable all disks, and then when we save it and send that RDP file, that's still persisting in that RDP file. Yeah, so it just forwards all of their disks, so it's just pretty much game over. So I got time for one more, I think. Yeah, it's a great question. So the question is, what do you have access to once that terminal service client is connected? Is that what you're saying? So it really depends. Most of the time, it's all the local printers. So I enable all the options in the RDP file when I'm targeting someone. And so what that means is you get the local printers, you get the audio devices, you get the camera, you get the video devices, you get any of the plug and play devices. You get any of the mapped network drives. So if like they have network file share that's mapped by default through like a policy, you'll get that. You'll get access to that. And you can read and write as within their permissions, right? So their ACLs on those network file shares, that's what you're restricted to. But yeah, you could write to pretty much anything across the network, clipboard, and then anything that's forwarded. So if they're running it in a VM, anything that's forwarded to the VM as well. So shared folders, clipboard again. Yeah. See, now you're thinking. That's exactly that's exactly where I went. Can I access the HLK, the actual registry? Because everything's a file. I haven't figured that part out yet because I'm limited to backtick TS client and then whatever's mounted. But that's where this research should be going. I think there's lots of really cool stuff that we could do, especially if it's elevated. If they're running from local admin, then there's a lot of stuff you could potentially do. So yeah, cool. All right, that's it. I think I'm up for time, but yeah, appreciate it. I'm not a huge fan of not using my laptop just because I prepare everything on my laptop, so like I know that it's gonna work.
I'm actually sorry about that, guys.